Hi, my name is M. Jagadish, Assistant Professor in CSC Department. Now here in this session, we discuss about object-oriented programming concepts in C++. Now we'll go one by one. Basically, the object-oriented programming concepts are nothing but like classes, objects, data abstraction, data encapsulation, inheritance, polymorphism, dynamic binding, and message passing. All these are nothing but the object-oriented programming concepts. Now we'll go one by one in depth. Come to the first one, that is nothing but a class. The class is nothing but a user-defined data type. Earlier, in C programming language, you already know what actually the user-defined data type means. User-defined data types consist like typedef, enum, structure, and union, which you already know in C. Here now, in this C++, we are going to learn about another user-defined data type that is nothing but a class. So basically, the first and foremost is class is a user-defined data type. Now, what actually it consists and how we are going to work with this class that indicates this class will hold its own data members and data functions. So its own data members and data function that indicates in which manner you define the data members in the structure in C programming language. Similarly, here also you have to define the data members and the data functions in a class, and these data members and these data functions are simply member functions can be accessed by using instance of the class that indicates objects. With objects we are accessing the data members and the data functions. Now take one more thing, you can also specify a class is nothing but blueprint for an object. A class is nothing but blueprint of an object. Once you define a class, then you have to execute the data members and the data functions of the class by means of the object. So simply you can define a class is like a blueprint for an object. Now come to the next one. You have an idea about a class, like it is a user defined data type which consists of data members and data functions. Now we make one step forward to know what actually mean for data members and what actually mean of data functions. Now look at this, the data members in a class. Data members in a class are nothing but the data variables. Similarly, member functions of a class are nothing but the functions which are used to manipulate on those variables which you specified in the class. See, look at this, when you work with the structure, in structure you specify the structure members. Generally the structure members are nothing but like these data members. Similarly here also. So in a class, here you are just go to specify the data members. The data members are nothing but data variables, and the class also consists the member functions. Now what actually the member functions means? These member functions are nothing but the functions which are using to manipulate or to perform some operations on these data members. So these data functions or member functions also defines the properties and behavior of the objects in a class. Now take a look of example. Now look at this here. Assume here we are going to take one particular example which is going to demonstrate a class. Now here I just go to specify a car. Then in this particular one, a car, you may have a different brands, different names of the cars, but even though all the brands of these cars are going to share some common properties, those are nothing but like every car has 4 wheels, speed limit, every car has a speed limit, mileage range, etc., etc. So each and every property must be specified when you just go to define a car. Similarly here also, in which manner the car has the properties, the class also consists the data members and the data functions which define the properties of the class. So this is nothing much the way how we just go to specify the class. Then come to the next one, that is nothing but the object. Now object is an identifiable entity or real world entity with some characteristics and behavior. Now you may have one doubt that what is mean by this identifiable or a real world entity. Look at this, when you just go to write something on the boards, either it may be white or black boards. When you are going to try to write something on the board, then definitely you have to use a piece of a chalk or a sketch pen. Then that piece of a chalk or a sketch pen is nothing but the object. Similarly, for example, assume if you are going to switch on a fan, then definitely to switch on a fan, the switch must be essential. So definitely again here, switch is nothing but the object. So likewise, the object is nothing but real world entity or identifiable entity with some characteristics and behavior which are going to perform some operation. In another way, you can also define object is an instance of a class. Object is an instance of a class. And one more thing you remember, when you just go to specify the objects, you just go to specify one more thing also. That is nothing but memory. Why? Because means if you define a class successfully, the class definition is completed, which consists of data members and member functions. But it will not create any memory to the data members and data functions until unless you create the object of the class. When you create the object of the class, then only the memory will allocates. So this is the way how we just go to define or create the object of a particular class. Then we have a look on one particular example which consists of a class and the object. Now observe here. Now here I just go to define a class with a keyword class. Remember, when you want to define a class, then you have to use a keyword that is nothing but a class. Then provide a class name. Here the class name is nothing but a person. Then open brace. And here in this example, I am specifying a data members as the char name of 20 int id. These are nothing but the data members. And come to the next one, public, it is a access specifier. And in the public parts, I just go to specify a function named as get details, void get details. This is a data function or a member function. Then close the class, semicolon. When you specify close brace and semicolon, it terminates the class. Then come to the main function. Open the main function, and it specifies the beginning of the program. Then here I just go to create the objects. The name of the object is nothing but the P1 for a class person. That indicates here the P1 is nothing but the object. When you create the objects, then only the memory will be allocated to all these things. Then close the object. Close the main function. So this is nothing but the example of class and objects. Now take one more thing. I already specified. When you just create the objects, then it takes the memory. Until unless there will not be memory allocation to data members and data functions. And it is nothing but like a record in Pascal or a structure or union in C. In C also, the memory will not be allocated to the structure members until unless you create the structure variable. Similarly here also. Then when you want to execute a program, when you just go to execute a program, you can execute a program by sending the messages of objects from one object to another object. Here, the objects are interacting with each other. In the form of messages. Means one object is sending message to another object. Similarly, another object will send the message to another object. So, and one more thing, when you specify the objects are sending messages to one another, then definitely object contains the data and codes to manipulate that particular data. The object contains data and code to manipulate that particular data. Then look at this particular one. Objects can interact without having to know the details of each other's data and code. For example, if you create the object like P1 and if you create the object like P2, P1 don't know the details of object P2. And similarly, P2 don't know the details of objects of P1. And without knowing the details, these objects are going to interact with each other. It is sufficient to know the type of message accepted and type of response returned by the object. That indicates when you just go to execute the functions by means of the objects, then definitely you have to specify what type of the object it is and what the object is returned. what the object is returned. These must also be specified when you just go to work with objects. Then encapsulation. Now look at this. Encapsulation that indicates encapsulation is nothing but wrapping up of data and functions together. Wrapping up of data and functions together in a single unit. In object-oriented programming, encapsulation is nothing but binding the data and functions together to manipulate on that particular data. We are placing the data and functions in one particular unit, and you can call it as a single unit. When you place that particular one as a unit, then you can call that particular one is nothing but encapsulation. Simply, if you make two persons in a room, if you bind the two persons in a particular room, then that indicates it is nothing but encapsulation. You are making them together, you are binding them together into a particular one, into particular room, then it is nothing but encapsulation. Now let's have a look about the encapsulation example, real life example of encapsulation. Assume that now there is a company in which there are different sections like accounts section, finance section, and sales section, etc., etc. Now take one particular section that is nothing but finance section. This finance section is nothing but responsible to do all the financial transactions, and also it keeps records of all the data related to the finance. That is a thing that is going behind of financial section. Now let's take one more section. Look at this. Similarly, we have a sales section. Now the sales section is going to handle all the sales related activities, and also this sales section also going to keep records of all the sales. So now take one more situation. Assume that there may arise one situation when one particular person wants some data related to the finance, some data about sales in a particular month. So when some particular data it wants from the sales section, the financial section wants the data from the sales section, then in this case it is not allowed directly to access the data on the sales section. The finance section is not allowed to access the data related to the sales section. First of all, he has to contact to some official person in the sales section, and then request him to give the particular data. This is what actually the encapsulation means. The other person is not allowed to a particular section. Similarly, here, the outside of the data or the outside of the function is not allowed to access the data or the function which is bound together in a single unit. This particular one is nothing but the encapsulation. Similarly, here the data of the sales section and the employees that can manipulate on this particular sales selection data. So, but not others. This is what encapsulation means. So look at this. Here I am making the methods and variables as a single unit. I am making the methods and variables as a single unit. When I make methods and variables as a single unit, then I can specify that is nothing but encapsulation. This encapsulation will also lead to data abstraction or hiding. Data abstraction or hiding that indicates it is hiding some data. That is nothing but abstraction. Data abstraction or hiding. Now come to the previous example. In the previous example, each and every section is hiding the details of particular sections. The sales section is hiding the details of sales. The finance section is hiding the details of finance. And similarly, account section is also hiding the details of accounts. Likewise, each and every section is hiding their own details. It is nothing but data abstraction. Now look at this. We'll go to the next one. That is nothing but data abstraction. So here the data abstraction is nothing but the most essential and important feature of object-oriented programming language. The data abstraction is nothing but most essential and important features of object-oriented programming in C++. First of all, abstraction means what? Here, abstraction is nothing but displaying only essential information and hiding the other details. What are the details that are essential to perform? What are the essential details are there? Those details will only be displays. The other details will be hidden. So here, that indicates what are the other details that are going to be hidden. That indicates, for example, now take one thing. If you want to know about one particular one, then the data which is reflecting the outside world, we just go to specify that data only, which is essential one. The background details is not necessary to know also. We compare with the real life example. Assume a man driving a car. When man driving a particular car, the man knows how to press the accelerators, which will increase the speed of the car, or else how to apply the brakes, which will stop the car. These things he know, but he doesn't know how properly the accelerator will works, how the speed is related to the accelerator, and how the brake mechanism internally the brake mechanism will works in order to stop the car. He knows only one thing: how to move the car, how to increase the car, how to stop or how to brake the car. These are the essential things. The background design details it is not necessary to know. This is what actually data abstraction means. Only essential things will be displayed. The background details will be hidden. You can do the abstraction in two ways: abstraction using classes and abstraction in header files. Abstraction using classes, that indicates using classes in C++. Here we are grouping data members and data functions together with access specifiers. When you specify the access specifiers, these access specifiers will make you visible to the outside world or not. If you make the access specifier as a private, the data will not be visible to the outside world. If you make the access specifier as a public, the data will be visible to the outside world. So likewise, you are specifying the abstraction by specifying the access specifiers in a class. And similarly, come to the next one, abstraction in header files. You already know the header files, which consists like the different user-defined functions or the objects in header files. And the best example is nothing but stdio.h in C and iostream in C++, which consists a multiple number of input and output functions and the objects. Now, for example, assume here we are taking one function POW, means power function, which is used to calculate power of a number. We simply call the power function which was there in math.h header file. We cannot go in depth about how the power function is working or how the power function was defined in math.h header file. We simply call. We are not going in depth about the underlying mechanism or the algorithm of power function. This is what actually abstraction means. The abstraction means. Now look at one more, that is nothing but polymorphism. Now we'll look at about the one more object-oriented programming concept, that is nothing but polymorphism. Polymorphism means having many or multiple forms. Poly, many. Morphism means forms. In Greek, we just have to specify poly means many, morphism means forms. Totally polymorphism means having many forms. You can define polymorphism as the ability of a message to be displayed in more than one form. That indicates it can exhibit different behaviors in different instances based on the type of data. That particular behavior will be done. So take one basic example here. C++ supports operator overloading and function overloading, which will relate to the polymorphism only, which is going to perform multiple actions in multiple ways. Now look at this particular one, operator overloading. Now in the operator overloading here, it is going to perform the different operations based on the type of operator. That indicates, for example, assume if you specify the operator as a plus. This plus operator is going to add two integer numbers. The plus operator is going to add two float numbers. The plus operator is also going to add two strings. So the plus operator is going to perform different operations. It can exhibit different behaviors based on the type of data that what you are providing. Similarly, function overloading. Function overloading means here we are going to specify one function name. One function name. This one function name is going to perform different types of the tasks. That indicates assume. Assume I am specifying the area. The name of the function is area. This function name is only one, but I can calculate the area of rectangle by specifying area as the name of the function. Similarly, I can calculate area of triangle by specifying the area as a function name. Similarly, I can calculate area of square by specifying area as the function name. So you look at this. I am specifying only one function name area, but I am performing the area of calculus or area of rectangle, triangle, square, and circle also. It can exhibit different performance. Now here we just go to specify an example. Here I just go to define a function which is going to add some integers. Sometimes it is going to add 2 integers, sometimes it is going to add 3 integers. The add function is going to perform the addition, but sometimes it will add 2 integers, and sometimes it is going to add 3 integers. Now look at this particular one. I am specifying only function name as sum. At the first time, I am passing 2 integers. At the next time, I am passing 3 integers. When I pass 2 integers, then the function call executes this module. When I pass 3 integers, then the function call executes this module. See here, in both the functions, the name of the function is the same, sum, but the number of parameters are different here. So based on the number of parameters and type of parameters and return type of the function, the appropriate function is going to execute among multiple functions. This is what actually function overloading means. Then come to the next one, that is nothing but inheritance. Inheritance is nothing but one more important object-oriented programming concept. Here inheritance means it is nothing but capability of a class to derive properties and characteristics from another class. That indicates here we are deriving the properties of one class to another class. What actually the inheritance means. It is nothing much what actually the inheritance means. So the major thing of inheritance, or the major advantage of the inheritance, is nothing much reusability. Reusability means something is already there, you have simply reuse. You cannot go to create and define again and again. So if, for example, if you want to create a new class, you can create a class. You can create a class, and if you want to use the code, if the code is already there earlier, then you just go to reuse that particular code by deriving a new class. By deriving a new class and add some other code to the new class. Now look at this. Here we have 2 types of classes. One is nothing much a subclass, and one more is nothing much a superclass. Subclass, that indicates this is nothing much inherit properties from another class, which is nothing much a subclass or derived class. Already one class is there, then you are inheriting the properties of that class to a new class, that is nothing much derived class or a subclass. Then similarly, superclass that indicates the properties are inherited by subclass. For which class the properties are inherited by a subclass, we can call that is nothing much superclass or a base class. These are the 2 types of classes, subclass or superclass, subclass and superclass, or subclass or derived class, and base class or superclass. So these are nothing but 2 types of classes that will be there in inheritance. Take a look at this one. Now I just go to specify a class with a name animal. Then this animal class is going to derive dog class, cat class, and cow class. Look at this. Here, dog class is getting the properties, some common properties from animal class. Similarly, cat class is also getting a common properties from animal class, and cow class is also getting a common properties from animal class. For example, assume in the animal class there is a property like 4 legs. So that 4 legs will consist in dog class, cat class, and cow class also. So the properties are acquiring, these properties are acquiring from animal class. The dog class is acquiring, cat class is acquiring, and cow class is also acquiring. So this what actually the inheritance means. It is getting or inheriting the properties from another class. Then this is inheritance. Come to the next one, dynamic binding. Now let's look at the dynamic binding. Dynamic means runtime. So in dynamic binding, the code to be executed in response to the function calls, which is decides at the runtime. Earlier, it is not known which code to execute until unless it is going to execute at the runtime. For example, assume that the same code is there in the program, the same modules are there in your function, in the main function. Assume you define one main function which consists 3 to 4 of modules, and all the 4 modules have the same name and same properties. Then which module is going to execute is it decides at runtime. Among for only one module has to execute. So which module is going to execute will decides at the runtime. We can call it is nothing but dynamic binding. Here C++ supports the dynamic binding in the form of virtual functions. Then let's have a look about one more thing, that is nothing but message passing. So here the message passing that indicates the objects can communicate with one another. We already specified in the objects concepts. The objects can communicate with another object by sending or receiving the information to each other. The message is passing from one object to another object. Object A is sending a message to object B. Object B is receiving a message from object A. That particular message passing is done in the form of the messages from one object to another object. A message from an object is a request for the execution of a procedure, and therefore will invoke a function in receiving the object that generates the desired results. See, if at all if the object is going to execute, then the object can execute a code by sending a message. So likewise, we just go to specify this particular message passing is done by means of objects. So this is what actually the message passing is. Thank you.